off. All right, recording in progress. Where's my notes? Got it. I will do some introductions of our presenters and then let them take it away. So the key presenter today is going to be Sam Becker. He's an environmental specialist from Shive-Hattery. Maybe getting things set up still. He's a asbestos inspector, certified lead inspector, asbestos management planner. He's got a Bachelor of Science in Civil Engineering from Iowa State, and basically just provides testing, monitoring, and design for regulated environmental hazards in buildings. And these guys can help clients manage and control the challenges of environmental hazards and help design solutions for those too. Then we also have Grant Bridgeford on the Zoom call as well. He's got 12 years experience in asbestos abatement design, radon testing, spill plans, SWIP design. I think that's what you call that. Can help clients with similar things like asbestos surveys and management, lead survey and testing, environmental scientists, indoor air quality investigation, and DNR EPA permitting. And Grant has a Bachelor of Arts from, I didn't see from where, I didn't copy from where, Grant, but environmental science. Simpson's College, that's right, good.
Yep.
All right, so I will just let Grant and Sam take over.
Thank you, Lisa. Assuming you can still hear me okay?
Yep.
All righty. So welcome everyone. Today we're going to talk about radon. As Lisa said, Grant and I work as environmental specialists, scientists, engineers. We take care of the environmental atmosphere within buildings for projects and for Shive-Hattery. So excited today to be talking to you about radon in buildings. So just kind of a brief overview of today's presentation. We're going to talk a little bit about what is radon, some of the facts about radon, testing, because that's mainly what we're here for today, is to talk about testing and what is testing, the devices, why you test, and testing what that looks like in your facilities. And then we'll talk about some solutions for mitigation, like what do you have to do if you have some high radon levels. So radon is a colorless, odorless, tasteless gas. You cannot detect it by the human body. It is just a natural radioactive breakdown of uranium in the soil, rock, and water into a gas. So it starts off as uranium. There's a lot of breakdown, decay of the material that eventually leads to the radon gas. Negative pressure allows radon to seep through cracks and poorly sealed penetrations of your building and becomes concentrated in your rooms or basements. So typically, the lower level of a house or a building, a basement, or some tunnels will have the highest level of radon. Anything that is contacting the ground. 4 picocuries per liter, or the PCI/L, that's the label for what the EPA set the action level to be. In Iowa, home tests around 8.5 average picocuries per liter. That's pretty high.
Hey, Sam.
Yes.
I can see your presentation, but someone else can't, and then but it's not advancing. I still see the first intro page.
Yeah.
Okay. Let me stop sharing and maybe try again.
Yeah, sometimes that fixes it.
Okay. I have the circle of death.
Oh, no.
Chrome is not responding. Grant, do you have the presentation up?
Let me pull that out here. Get it here momentarily.
I don't know what's going on.
I could probably open it. And if you don't have it going, Kirsten, can you make Grant a co-presenter, whatever it is, so that he could share his screen if he's going to do that?
Yeah, I can do that.
Sorry for the technical difficulties.
It happens.
Sam, I'm trying to find out invitation.
Let me see if I can open it. Guess what? I think I beat you to it.
That would just be my luck.
Why don't I just share?
That's the wrong file.
Whoops. Oh, I know what the deal is. You have to. Sometimes it does weird things. Sometimes you can't view it as a presentation. All right. We might just have to look at it in not the prettiest presentation mode. Can anyone see a radon presentation?
Yep.
Yep, it's there.
See a set of lungs.
Set alongs. All right.
Perfect.
Where you were, Sam? Or were you on to radon facts? Yeah, you were
Yep.
on to radon facts. I'll try and keep up with you. Are you there, Sam? Uh-oh, did we lose him?
I don't know.
Looks like he's there.
Yeah.
Can't hear you, Sam.
G data shared. We got it.
I have him as co-host.
I sent him a message. Sam, can you hear us?
Yeah, I just sent him a message on Teams too. Oh boy. Still, I mean, okay. He might need to sign out and get back in.
Okay.
'Cause
Yeah.
He just asked if he was still on.
Nope.
It
Hey,
shows him.
Sam's getting back on his regular computer. You can roll the presentation, but he's getting hooked up right now.
Well, I'll finish off this slide here, Lisa. Sam was talking about home testing or the action level for radon is 4 picocuries per liter. Picocuries is what radon is measured in. Pretty much the EPA has stated that if your radon levels are over 4.0, EPA recommends some way of mitigation to try and reduce the levels in either your house or large building or facility. In all honesty, there is really no safe level of radon in a building. Any level elevated means that you are still breathing that air in. 4.0 picocuries has just been an EPA action level that they feel is something that is a number that they propose to be the action level to have it reduced below that. But as many of you may not know, radon is the second leading cause of lung cancer behind smoking. And it is approximately equals about 21,000 deaths per year in the United States.
Grant, I'm back on. Can you hear me?
Yeah, we hear you. Yep. We're on to health
Alrighty.
effects.
Okay. Well, thank you for taking over. And good thing we have two of us.
Sure.
Yep.
Okay. So the because radon is undetectable by the human body, we breathe it in without really knowing what and how much we are. So a really cool little video that I have on here shows what happens when the radon particles get into your lungs. If you could click on that link, control, and then click. Jump to about 1 minute and 8 seconds or so. There you go. So this is one of the examples of a gas within the chamber. This is a cloud chamber. It is basically made to see radioactive decay. They're going to pull this out and they're going to put in a radon gas tube. It's really cool. This is what we call in our office geeking out. So here's the introduction of the radon as would be maybe in your lungs. All those little lines are the decay. And with that decay comes tiny little explosions. And those explosions are what cause the damage to the cells in your lungs. So,
And do we know what level of radon was administered in this test? Like,
no, probably a lot.
Yeah.
But it just, overall shows,
Right.
each of these little alpha explosions at different types of radiation.
Yep.
So, yeah.
Good.
So thank you for that.
All right. All right. Let's go down.
Alrighty. So to go from health effects to some geography, radon is widely spread across the U.S. The first map there shows all the areas of the United States in different colors, red being zone 1. That means the highest level of radon, average 4 picocuries a liter or higher. And as you can see, every county in Iowa is in zone 1. So Iowa is known for having pretty high levels of radon, as we saw earlier with the 8.5 average in homes. This just kind of basically redefines what we already kind of talked about, 4 picocuries per liter, what a radon is. What I want to focus right now on this slide is there's no safe level of radon. You may be under, a test may show you under 3 point, under 4, but really there's no safe level of radon. The longer that you have an exposure, the more at risk you are of developing a disease. So to get into the bulk of the presentation here, radon testing in facilities, and that's what we're all here for. I just have listed there a number of facilities that we work with on a regular basis, and that a radon could affect. So the actual radon testing, you can do a short-term or a long-term test. Short-term tests last between 2 and 90 days in length. Long-term tests is anything over 90 days. The industry standard is for short-term testing, generally 2 to 7 days. And that was brought on primarily by the real estate transactions, because you can't reasonably, expect to run a 90-day test in trying to sell a house. So the rest of the industry has taken on doing 2 to 7 days of testing. So who can do the testing? Well, licensed third-party consultants are a good way to start. They provide professional solutions. Most of the time, though, a building owner can do the testing themselves, but that also depends on where you are geographically. Maybe some of the local laws or codes. Maybe you have some funding sources or an insurance requirement. You need to be kind of up to date on that sort of stuff and do your research. So, but the main thing is, why are you testing? Testing is the only way to know that you're at risk. Most devices are capable of doing short-term and long-term testing. And once you send those off to the lab or have someone read them, their reports are generated pretty quickly with detailed and easy to understand information. There are a multitude of different ways that you can test for radon. The main ones being the one here listed on the screen. Alpha track, look like the little top hat there. EPERM, we're going to talk about that next. Charcoal packets or canisters, those are the most common ones. You can buy those at a hardware store, do the testing yourself. A lot of companies will end up using these just because they're the most readily available and probably easiest to use. And then you have your continuous radon monitors, which are good for a home or a single room testing, but they're not very feasible for doing a large building when you have 50 to 100 rooms that you're trying to do at the same time. So that just gives you a continuous read on radon. Okay. So the EPERMs are what we use here at Shive, and they come directly from the factory with a set charge. There's an empty chamber. The radon and the gases in your room will go into that chamber, and the change in the voltage on that little plate inside the chamber is proportional to the amount of radon during the exposure period. A software, we can read those here in the office with a voltage reader, and then our software program can calculate the average radon level for the room for that device. It's a true integrating device, as results provide over that whole exposure period rather than the hourly measurements like a continuous radon monitor. So here's an example of a report that you might see from someone doing a radon test. This is for a basement. 2 samples were taken. As you can see, it has the location, the start and end date and times, and the results. So I would say these results are pretty good. One's at 1.0 and the other is at 0.9. So fairly low for Iowa. So in order to start your testing, you need to establish a radon testing plan and schedule. The schedule being typically during the colder months when windows are closed. If you think about it, if you have testing during the summer and you have windows open, the air is going to be diluted with the outside air, and so you're not going to get an accurate representation of what the radon levels are inside your house, in your house or building. And so you'd like to do that during the colder months because you aren't as tempted to open the windows. So communication with the building occupants about the testing is essential. This is especially true with schools because you have lots of curious little hands and minds wondering what these things are. And so it's important to let the teachers or your staff know that this is going on, so that way you're not bombarded with a million questions. The number of samples in a building is determined prior to the testing using floor plans and maps. So we like to mark up kind of where we'd like to do the testing, and that gives you a better price, a more accurate price at least for doing the actual test, rather than just giving you a general like, oh, it's $12,000 for this building. So we like to use those maps to be able to get the accurate number of samples. So every test will be generally ground floor contact occupied rooms are the ones that need to be tested for 2 to 7 days. That's kind of the industry standards I talked about. The number of samples will be more than just how many rooms you have, because we're licensed, and so we have to do the duplicate blanks and spikes. It's all a matter of measures, quality control measures, excuse me, that we have to do. So just make sure that you get the most accurate results possible. Good. So to get into some of the facilities, childcare centers are out. The radon testing is actually outlined in the Iowa Administrative Code. So if you have a building with a childcare center, this is where you would see it. Basically, within 1 year of getting your license, all childcare centers need to have radon testing done. If the testing determines that you have an excess of radon, then you need to develop a mitigation plan. And once that mitigation plan is concluded, then you need to test every 2 years after that. So that just shows that there is something in place for childcare centers. Skip that slide. Schools, actually just in Iowa this year, back in July, had a law passed, House File 2412. It was introduced, passed, and signed. And this is really exciting because we in the radon industry have been wanting this for a long time. I mean, it should be important for everybody because we all have kids, in school or did at one time. And so the teachers and people that spend a lot of time in those schools now are protected because the school districts have to do radon. So this is just another things that shows in Iowa schools do have to be tested now. So in just more general larger buildings, higher ed, office buildings, industrial, retail, commercial, even healthcare, testing is really at the discretion of the owner. A lot of funding requirements will push whether you have to do testing or not, when, maybe some local ordinances. Industrial buildings tend to have their own environmental compliance plans, which include a lot more than just radon. So, and every slide that I have here, I always have a recommended use. The EPA has documents that they've put together that are recommendations. Yeah, Grant's showing it up there. It's the protocol for conducting measurements of radon in schools and large buildings. And that's always something we like to use because it's a standard, and that way we're being consistent for every test that we do. So multifamily buildings are kind of get their own category, and they are a large building, but if you have an apartment with more than 4 units, then it's considered multifamily. The recommended use here is for it's the same thing basically, but multifamily. The guidelines are pretty much the same, but it is geared more towards having multiple families in one building. A lot of times HUD or local ordinances actually do apply to these, especially for funding or depending on the type of multifamily building. So just something to keep in mind.
Hey, Sam, there's a
Yes.
in the chat.
Yeah.
See higher radon numbers with slab on grade, or if the house has a basement.
Yeah. So basements do have a lot more radon. However, we don't discriminate because the slab on grade could be over a pocket of higher radon, and you don't know until you test. I don't know if there's a study or anything done that shows the difference, but that's why they say just any ground contact floor would need to be tested for radon. So even if you don't have a basement, all of those rooms in contact with the ground still can get that radon up in there, and then they still get in there. Now, one thing I didn't mention is that new buildings compared to old buildings, one would think that, oh, it's a new building, you may not have as much radon. Well, new buildings are actually sealed more, and tighter. And so if you do get a radon leak within there, that radon has less of a chance um, to not escape. And so it really doesn't matter if it's a new or old building. You, that's why you just need to test.
So my leaky out house might be okay for some as far as radon.
It could be okay if you have a lot of airflow, but also the leakiness will bring in more radon. So,
Oh, geez. All right, fine. There's another question. Why do we see such high rates of radon in Iowa? Are we sitting on some type of radon mine? That was Kevin.
Grant, do you have any background in geography?
Yeah, no, that's due to the glacier movements across the United States. Turned up a lot more soil and pretty much came to rest just down in Missouri, but a majority of Iowa was all pretty much carved into by a glacier, which means that a lot more uranium was disturbed in that process, which is also why Iowa is like one of the most fertile soils to grow crop on. But it's also the breakdown of the glacier movement, which has caused a large pocket of radon to be dispersed across the state.
Lovely. All right. Should we move on?
Yeah, let's do it. I'm going to blur my background there. Okay. So now we'll move into assisted living nursing homes. The reason I have this one as a separate building is because they have their own, typically, standards. So these facilities still allow 25% of your ground floor units to be tested initially. So you don't necessarily have to test all of your ground floor units. You can just do 25%. However, if one of them comes back over 4, then you have to test all the units just to see. So it's kind of in a way to assist in the decision-making process. That is typically under a HUD ordinance there for funding and stuff. So,
okay.
Yep. So rental properties, I wanted to put this one in there mainly because in Iowa City recently passed a code that says that all rental properties need to be radon tested before they can be rental properties. And there's some follow-ups there and stuff too. The city of Marion also has an ordinance. So kind of depending on where you are, it'd be good to know what your local ordinances are before deciding to go in on a rental property or renting, to know what your rights are. The EPA published a home buyers and sellers guide that gives good information to landlords about these protocols for testing. So, low cost, testing's not that expensive. It's peace of mind. You can self-test or use a third party. So there currently are no state-wide disclosure requirements for testing or mitigation, but that's where those local ordinances do come in. So finally, on residential, testing is obviously at your discretion. You can test or not test. It's up to you. The EPA recommends testing your house every 2 years, and that's mainly because radon levels can fluctuate. You may test initially, and it may be at 1, and then 2 years later it may be at 3.5. It's like there's a lot of reasons radon levels fluctuate. It's the pressure in your home. Maybe you did a small renovation, or you had to replace your furnace. A number of things will cause your radon levels to fluctuate, which is why it's important to test, about every 2 years or so. Even though homes do not have to be tested before being sold, Iowa does have a radon disclosure law for home buyers and sellers. So just something to keep in mind there. Radon stays with your house. So every 2 years for homes, about every 5 years for schools and large buildings. It seems to be the industry standard now, especially with this new school law, is what they did for 5 years. That's kind of what the EPA recommends. And then it's important to think about testing after you have a significant change to your building. Let's say you've had your HVAC replaced. Maybe you have a building addition or renovation that will change your airflow and pattern through your building. Any natural disaster that changes the building, or obviously the installation of a mitigation system, you'd want to test after that to make sure it's working appropriately. So you have high results. Let's say you get some high results. Now what? Well, as we've determined, the EPA action level is 4. So anything over that would require an action. For every test that is above the limit, that space should be retested. Do not mitigate based on one test. Who knows what that test, the conditions were at that one test. You want 2 to confirm. So the average of the first and the second test will give you that level, above 4 or below 4. That will be your determining factor, whether you need to think about mitigating. And then obviously you test just to make sure that mitigation system is working. And January is Radon Action Month, so this is a perfect time to be doing this. So now we'll just quickly move into some mitigation strategies. Here's a couple pictures that I thought were good. These are obviously geared more for houses, but all of us live in houses, and so we may or may not have a radon system installed already. But this is kind of what they look like. The general idea is that you have a pipe that goes under your slab into a gravel-like material where it is creating a negative pressure suction, and then it's being piped up through the house, whether through the house or on the outside of the house, with a fan that helps that suction. So that is how it reduces the amount of radon underneath your house and exhausts it out at a certain point. So that way it doesn't come in. Okay, so in new construction, we call it's radon resistant construction. So that is basically something that happens in the design before construction begins. So if you're planning on building a new building and you want to make sure you're putting in some of these measures, which anymore is pretty common, but gas permeable material like gravel under the foundation, followed by a layer of plastic or impermeable sheeting. Pipes are generally laid, as you can see in the picture there, through the gravel, and this helps. And then once that's all covered up with the slab, the radon gas only has one place to go, and that's in those pipes. And so the foundation is then laid over all of that, and it's sealed. All openings and cracks are sealed, and so that way the radon really is diverted into that one space. The benefit of using this is that it can be done during and before, during construction, and it could be placed inside your building, venting through the roof. This prevents a lot of kind of wonky systems that you see on houses that are on the outside. It's because they were put in after the construction. So, and it saves, in the long run, for money just doing it up front. So some mitigation strategies for new construction. It's not required in Iowa, but recommended. And to install a passive system will keep the soil gas ventilated. So putting that pipe in, but not activating it. So if you don't have a fan, that pipe will still help get the radon out. But you won't know that for sure until you test after the building has been occupied to know whether to activate that system, whether to put a fan in. Maybe you need a little extra, suction under your slab to get that radon out. The state of Iowa does recognize the EPA, a standard basically technique from the EPA. The state of Iowa does for standards for building new buildings for radon. So, and as I said, many builders already incorporate it. We just bought a new house and it already had the radon resistant construction within it. So.
And we did have a question that came through. Do you ever have to replace a fan on a mitigation system? Do you need to have these systems tested ever?
So the radon, that's a good question. The radon mitigation systems and fans are always running. If you have a fan, it's always running. So they do wear out. I'm not sure what the typical standard time for that is, but it does have a small little like manometer tube with some liquid in there. It's always supposed to be at a certain level, and if it's important to check that level consistently, because if all of a sudden that it's different and showing no pressure within your system, that could mean that your fan is not working. There's generally not any tests that need to be done regularly for the fan or the mitigation system. It's really just to make sure it's working. And then if it isn't, call the number on it's supposed to be labeled with the company that put it in, so that way they can come in and service it. Great question. So now we'll kind of get into, that was new construction. Now we can talk about the mitigation strategies for existing large buildings and schools. Every building is different. You have buildings with basements, you have buildings with slab on grade, you have crawl spaces and tunnels. So the mitigation strategy for any one building is going to be different than the next. If testing results in levels over 4, I'd recommend consulting with a mitigation professional for a quote and opinion regarding the solution that would work best for your building. There's no blanket solution for everyone. However, there are things that you can do in a facility before turning to a mitigation professional. Sometimes basic engineering controls make all the difference. Maybe your HVAC system is not working appropriately and you need to make sure that it's working as it's designed. You need to bring in more fresh air. During COVID, that was a big deal. We needed more airflow. We needed more fresh air. It was encouraged to upgrade HVAC systems. The more air changes per hour within a space helps not only viruses, but helps CO2 levels and less radon. So keeping equipment maintained and working properly is important. And then also kind of a interesting one that you may not think about is just making sure all your louvers and vents and intakes are clean and open. I've been to so many buildings, whether office buildings or schools, that people like to decorate their area and they cover up their intakes or louvers on the ceilings with stuff. And that prevents the natural airflow that the HVAC system is trying to do. Overall, you can increase the air movement with fans or windows, or just turn the HVAC up a little bit. If it's nice out, crack a window open. All that increased air movement will help reduce radon levels. For small buildings and residential, it's pretty much all the same. It's just that you're making the decision for your own home. The typical mitigation system for a small building, as you saw in those pictures, was your standard vent, fan, pipe through the basement and out to the outside. Mitigation systems in a small building and home are easy to install and pretty affordable compared to the risk of not mitigating. So, all right, and just kind of to wrap it up here, we at Shive, and this has to could be for all the environmental firms, the big ones at least, provide a number of different services. Mitigation contractors, I would say, do testing, but I just be cautious with hiring someone to do your testing and then the mitigation. It's good to have a third party to help consult with about solutions first. So here at Shive, Lisa kind of said a little bit of this while in our introductions, but there's a lot to think about in a building. So not only radon, but if you have an older building, there could be asbestos. And even in newer buildings, if you're doing a renovation, an asbestos survey is required. Mold is an issue, and no one likes talking about the black mold. That affects indoor air quality, the breathing, people's health, overall indoor air quality, air permitting. If you have boilers or generators, there are specific requirements for permitting those. Water testing and quality. We do a lot of drinking water testing for schools just to make sure like lead levels are appropriate. Because sometimes in older buildings you may still have lead pipes, or the city may have lead pipes that lead up to your building. And then any hazardous materials and other types of programs for hazardous materials. So yeah, we do a lot of large buildings, and it's good that I feel lucky to be at Shive because we have a lot of different professionals within our company that we can turn to. So sometimes being able to get a multiple opinion in your building, maybe from an architect or a mechanical engineer, will be helpful to help answer some of your questions about your HVAC system or airflow patterns. So, alrighty, I think that's basically it. I'll leave you with the map here, and I think we have the last slide just has our team on it, and there's all our smiling faces. And yeah, thank you for everything. Grant, did you have anything quick to add?
No, I think you pretty much said it all. I will add in there that mitigation, when it comes to actually mitigating a property, costs have actually drastically reduced over the past decade as to when I initially started my services back in 2011 or 2012. Regular homeowner install for a mitigation system was roughly around $5,000 to $6,000. Recently, my previous home, I had to have one installed, and our contractor was able to do it for about $1,400. So costs have drastically reduced. It's pretty much due to technology and also knowledge of testing the space and the actual areas that actually have to have suction points installed into a home or a large building.
Nice. Anybody have any other questions? Well, we have these guys, captive audience here.
So if we wanted to test our house, is it as easy as going to buy one of these, I forget the name, system that you'd mentioned?
Charcoal kits are the most common test found in a lot of hardware stores. And those usually list the instructions on it and where you can actually send the kit to actually have it analyzed.
Are they good? Are they okay for testing, or is it better to, I don't know,
I've used a multitude of them. So activated charcoal kits are really common, really easy. They kind of look like a Hot Pocket canister that you can get from the store. But yeah, instructions, it'll pretty much give you a step-by-step, open the pack, hang it on a wall, leave it alone for 48 hours, seal it up, and ship it to the laboratory that's should be listed on the packet. And normally within a day or two, that laboratory will be sending you the lab result.
I'm just curious, can you read this thing here at the office?
We use ePerm systems. What Sam was talking about, we have
The voltage reader.
the voltage reader that actually reads those kits. So we have the ability to actually sample and read the same kit and give you a lab result
Instantaneously. Yeah.
Yep.
Interesting.
Yeah, and those kits are good, you know, especially for just wanting to get some more information for your building or your house. However, there's, you know, obviously you guys know this, there's benefits to using a consultant or third party just because you have the professionalism to back it up and you are able to, you know, figure out solutions more than just getting a result back and being like, now what? So.
Sure. Yeah. Great. Thank you.
You're welcome.
Anybody else? Questions?
Quick question on, like, if you're in the basement or whatever else and the concrete or the slab has cracks in it, do those type of things need to be sealed first for then the mitigation to take the radon out, or how does that work?
Part of your radon mitigation system is going to include your basement slab being sealed with the cracks. So they're going to want to address that because otherwise it's the actual system you're paying for is not going to work as well as it could without those cracks being sealed.
Okay, thank you.
All right, if there's no more questions, we'll let you guys go a little bit early. Thanks, everybody. Thanks, Sam and Grant, for
Yeah, thank you, Lisa,
information.
for
Thanks.
helping us out. So
All right.
thanks, everyone.
Thank you.
Yeah, thank you.